What's going on, everybody? Johnny Bannon here with Trepa Technologies, and in today's video we're going to be going over dynamic ARP inspection. This is going to be another video going over layer 2 security in our CCNA free and full course. So if you like these videos, please feel free to like and subscribe and share it with anybody you know, anybody that wants to become a network admin and get CCNA certified. And we also offer live, virtual, and self-paced training, full courses with over 1,000 practice questions, labs, access to our team, and lifetime access to our learning management system. Now, with that sales pitch out of the way, let's go ahead and begin to go over dynamic ARP inspection. So, the first thing we're going to go over is our agenda here. What is dynamic ARP inspection? We're going to go over a quick overview, and then we're going to go over ARP again and gratuitous ARP. So just touching again on what ARP is. As you know, if you've been watching our series of videos in order, we've already went over ARP, did an ARP lab. But to understand what dynamic ARP inspection protects from, we're probably going to want to do a quick ARP review, because even though I've been doing networking for so long and now teaching it for a while, I still always kind of have to read about ARP again. So we're going to have to do a little review, right? Even though it's easy, it maps layer 3 to layer 2, but the actual process, the request and the reply packets, we're going to do an overview. Then we're going to go over the kind of attacks we're protecting against. So we're going to go over what is an ARP poisoning attack. So why do we need dynamic ARP inspection? Because of an attack called ARP poisoning. And then we're going to get into the operations of dynamic ARP inspection, as in what are the untrusted and trusted ports do? How does it work with DHCP snooping? And what do you do if you have a static IP that's not in the DHCP snooping binding table? So the actual operation of how we filter with dynamic ARP inspection. And then of course we're going to go over quick configuration overview and verification, and then that'll lead us straight into the lab. Okay, so a quick DAI or dynamic ARP inspection overview. So dynamic ARP inspection is going to protect your LANs, your campus network, and your LAN architectures from threat actors that manipulate the ARP process. Remember, the ARP process maps layer 3 to layer 2, and it does that by sending out ARP requests and replies that are broadcasted throughout the LAN and your broadcast domain. So DAI, or dynamic ARP inspection, is a security feature enabled on switches, and it only affects ARP packets. So when we enable dynamic ARP inspection, the only thing it's going to filter is ARP packets. Non-ARP packets are not affected. So just ARP, guys. It won't affect anything else. Now, of course, if you can't resolve, right? If you can't build an ARP table, well, then you're not getting anywhere on the network. But again, as the protocol itself, or as the technology itself, dynamic ARP inspection only affects ARP packets. So how it works is DAI, or dynamic ARP inspection, will use the DHCP snooping binding table to verify the layer 3 to layer 2 mappings. Again, if you're watching these videos in order, you should have already watched the DHCP snooping video, where we showed you that when enabled, it creates a binding table that says, hey, this IP address belongs to this source MAC address, okay? So that binding table with that information sounds a lot like ARP, right? So by default, dynamic ARP inspection will use that binding table to verify layer 3 to layer 2 mappings to help prevent those ARP poisonings. And we'll get into what ARP poisoning is, and then how it uses that layer 3 to layer 2 mappings on the binding table to verify that we don't get a rogue user that's saying, hey, I'm the default gateway, by manipulating ARP, okay? Now you may be wondering, well, hey, some of my devices are going to be static, and we're going to architecture them like that. They're on purposely static, like printers, VTCs, anything that is going to resolve DNS. We want a static IP, correct? If dynamic ARP inspection verifies layer 3 to layer 2 mappings based off the DHCP snooping table, but we have static IP addresses set, well, then it doesn't offer us any protection. Well, it can also optionally be configured using something called static ARP ACLs, or configured statically using ARP ACLs. And that's where you go in and actually say, okay, hey, check it out. This layer 3 IP address belongs to the source MAC address. You actually do that from the CLI in global configuration mode. We call that an ARP ACL, okay? Dynamic ARP inspection is going to inspect and filter ARP messages on untrusted ports. So similar to DHCP snooping, we're going to have trusted ports. And trusted ports are going to be for any connection that's to our network infrastructure, not endpoints, okay? So trusted ports are configured for any connection, any port connecting to network infrastructure. So routers, switches, firewalls, right? I'm always bad at it, right? All of a sudden when I get on the camera, guys, I can't spell, but network infrastructure. And then the untrusted ports, these are going to filter the ARP messages, right? So we're going to get into when we get into the operation, how it filters on inbound traffic. But this is going to be for client or endpoints. You're going to set ports untrusted, which is by default, but the untrusted port should be any port that's facing an endpoint. So we look at this switch here, we can see that this server is an endpoint, this is an endpoint, this is an endpoint. So all three of these ports, 1, 2, and 3, are going to be untrusted, okay? Now the reason is because these untrusted ports are not going to allow any ARP replies inbound. And again, we'll get into that when we go over ARP again and ARP poisoning in the operation. So now let's do a little ARP review. So what we're going to look at now is how does ARP work again, okay? So remember, in the life of a packet, let's say I'm host 1 here. And host 1 creates a packet that says, hey, here's the layer 3 header. My destination IP, we'll put DIP here, is 8.8.8. So now it's going to recognize that that 8.8.8.8 is outside of its network. So now it has to send this packet to where? The default gateway. Well, it does that by building a layer 2 header. And in that layer 2 header, the destination MAC address should be the default gateway's MAC. Okay? Now, if this host is IP address is set statically, or if it even got it via DHCP, how does it know the default gateway's MAC address? Well, it doesn't, because it doesn't have that layer 3 to layer 2 mapping automatically. What it needs to do is send out an ARP request. So again, we have our host here. Let's say, I'm going to draw this a little bit bigger. We have this layer 3 header, life of a packet, right? The source IP, the destination IP is 8.8.8. These don't change, right? Source IP and destination IP don't change. And then we have its layer 2 header. So it's going to look in its ARP table and say, I don't know the default gateway's MAC address. So now I have to send out an ARP request. So in that ARP request, we're going to have, in the actual ARP request, the target MAC address and the target IP address. So as of right now, we don't know the MAC address for the default gateway. So we're going to broadcast this ARP request out. And in the actual ARP message, we're going to be saying, hey, who has whoever this IP address is, tell us your MAC address. So that ARP request is going to be sent out all active ports, because if you look here, broadcast MAC address is the destination, right? And once the default gateway receives that, it's going to look inside that ARP packet and be like, oh, hey, you're looking for me. I'm 192.168.10.1. Well, let me respond to you in an ARP reply, and say, hey, here is my MAC address. And now once we get that ARP reply, we're going to populate our ARP table, and it's going to say 192.168.10.1 is equal to this MAC address here. So I'm not going to write that whole thing. I'm just going to put .114. And now, when it builds that packet again to do a DNS request to Google, it can actually build the entire packet with the correct source MAC address of itself and the destination MAC address of the default gateway. Whew! That is ARP, guys, right? That's ARP in a nutshell, and this happens instantaneously, okay? Well, let's say the first time you ping, right, it happens. And then your ARP table is populated. Now, if we actually go ahead and take a look, if we take a look at ARP, let's actually bring up an ARP table here, guys. So we go to terminal, we'll type in ARP-A. We can see here that even on my MacBook, we have a little ARP table. And it's going to say, look at the default gateway here, this is its MAC address. So when I need to make a connection out, like if we look at our NetStack connections, ooh, I'm used to Linux sometimes, guys. That was ANTP's my go-to for Linux. It makes the NetStack command come out really clean. But as you can see here, when I'm going to these destinations, when I build my packet, it's going to have in that layer 2 header, when I'm trying to talk outside my LAN, outside of my 192.168.0.1, so I'm talking to this server here, guess what? My destination MAC address is this guy. And my MacBook, my computer knows to do that because of this ARP table right here. Now, if we actually go ahead and take a look at a packet capture, I'm going to bring in to the screen real quick. If we look at this ARP request, check it out. We look at the layer 2 header. The destination in this ARP request is all Fs, that's the broadcast MAC address. And then in the actual ARP packet, we're going to say, hey, this is our target IP address, okay? Who has this MAC address? Or target IP, tell us your MAC address. See how it's empty here. And then this ARP request is saying, hey, I have that, okay? I have that MAC address. So as we can see here, this is the request and saying, hey, whoever 10.10.20.5 is, I need your MAC address. Once 10.10.20.5 receives that, here's the sender, it's going to fill that information in, right? Because this is its MAC address here. And then once that reply gets back to our sender here, 10.10.20.1, it populates that ARP table and now has its layer 3 to layer 2 mapping. Okay, now before we get into ARP poisoning, one thing we're going to have to cover is something called a gratuitous ARP. What this is essentially an ARP reply packet. And if you notice, we look at our ARP reply packet again on Wireshark. An ARP reply packet has all the information. It says, hey, this is my MAC address with my IP address. And let me look at that reply. This is my MAC address with my IP address. Here's this target MAC address. Here's its IP address. So pretty much that ARP reply contains all the information. It contains that ARP mapping, right, that you need. So what a gratuitous ARP is this is an ARP reply packet that's going to be broadcasted out to the whole LAN. If you notice here on this ARP reply, we don't need to broadcast it out because we know who we're sending it to because that ARP request has that source MAC. So now that source MAC in the ARP request is the destination MAC in the ARP reply. With a gratuitous ARP, the destination MAC address is all Fs. So essentially what this does is this tells the entire LAN layer 3 to layer 2 mapping. Now, let's think about that. If our PC down here, host 2, wanted to be malicious and wanted to say it was a default gateway, it could send a gratuitous ARP out to everybody and say, hey, no, my MAC address is 192.168.10.1, okay? It could put that in the target area of that gratuitous ARP. So now the entire LAN's gonna be like, oh, okay, the default gateway's MAC address changed. Now I guess I gotta send information here to my malicious actor here, okay? If you actually look at that gratuitous ARP, if you check it out, right, we can see that MAC address. So it's sending out to all. And you can see here, this is the information that's going to populate the ARP table, okay? That, again, that layer 3 to layer 2 mapping. Now, ARP poisoning. So ARP poisoning could just be someone sending out that gratuitous ARP, or it could be a man-in-the-middle attack that's going to manipulate the ARP tables of devices. Essentially, ARP poisoning could be someone manipulating that gratuitous ARP, or it could just be host 1 sending an ARP request out, looking for the default gateway, and this malicious threat actor responds before the default gateway responds and says, hey, check it out. I'm the default gateway. Make sure you send to me. And there we have ARP poisoning. And once we understand ARP, the request and reply communication, ARP poisoning is very simple, right? It's just someone sending out bad ARP information to populate your ARP tables with the wrong layer 3 to layer 2 mappings. Now, if we go back to dynamic ARP inspection, think about it, guys. What if we could tell these ports that inbound, when you receive, you can only receive ARP request. Then that gratuitous ARP this malicious threat actor will send, or that ARP reply that to host 1 that it potentially could send to do ARP poisoning. If we tell this port, hey, only accept ARP request, guess what? It's going to drop that packet. And that's exactly what dynamic ARP inspection does. So what dynamic ARP inspection will do is it's going to inspect the sender MAC and the sender IP address in the ARP packet and compare it to the DHCP snooping binding table. And if that MAC and IP address match, the ARP packet will be forwarded. So it's only going to do this inspection on untrusted ports. So it's going to rely on DHCP snooping to be enabled, but it can also be configured manually, statically for devices in your network that aren't DHCP. And again, we talked about that. It can use those ARP ACLs, okay? So dynamic ARP inspected trusted ports are typically connected to other network devices or devices with static IP addresses. So another way we could just get around that static IP address is just say that's a trusted port, okay? But again, what it's going to do on our untrusted ports is that if it gets that ARP reply, it's going to inspect it, make sure that it matches the DHCP snooping binding table, and then drop it, okay? And again, in that ARP reply, if I bring up my Wireshark capture again, it has that information, right? It has the sender and target MAC address. So it's going to make sure that all this information matches the DHCP snooping binding table in that ARP reply. It's going to ensure that this sender MAC address and this sender IP address match in the DHCP snooping binding table. And if you see right here, we have some configuration. So if we want to do trusted ports, it's just IP ARP inspection trust. And another way this configuration differs from DHCP snooping is just one command. IP ARP inspection VLAN 1, 10, 20, whatever VLANs you have. Whereas DHCP snooping, remember, it was two commands. It was IP DHCP snooping, and then again, IP DHCP snooping VLAN 10 or 20. But with dynamic ARP inspection, it's just IP ARP inspection, and then you tell the VLANs, okay? Just one command to enable it. And again, this is going to be built off the DHCP snooping table. So if we type in this command, IP ARP inspection VLAN 1, without DHCP snooping being enabled, not going to work. No bueno. Additional optional configuration we can do is we can also configure rate limiting. So we can say, hey, only allow this many ARP packets per second. So a little bit different than the DHCP snooping rate limiting with dynamic ARP inspection rate limiting. This is on a packets per second basis. So we can adjust how many packets can come in per second. So right here, this is the default. So we're saying only 15 ARP packets can come in per second. However, we can change that. You can see we did that here on gig 02. We're saying only 40 ARP packets can come in every 3 seconds. So you can have that packets per second interval or just keep it at the default. So we have a little bit more control and granularity in how we can accept and configure rate limiting. Now for verification. So we have a couple of verification commands. We have show IP ARP inspection interfaces, and this will show us what interfaces are trusted, which ones are untrusted, and their rate limiting. And then there's a couple other commands that I don't have in this PowerPoint that we will go over during our lab. Another thing we might touch on the lab is actually configuring the ARP ACLs. That's not in the CCNA exam objectives. It doesn't say you need to know how to do ARP ACLs. It really just says that you need to know about dynamic ARP inspection and its configuration and verification. So you just got to know about it. It doesn't say you actually need to know how to configure it. But we're going to still do a lab on it, okay? Because we got to know how it works, how it functions, and the best way to do that is hands on the keyboard. All right, everybody. I want to thank everyone for viewing. And if you want some training, if you're an active duty National Guard or Reserve soldier, we are an Army Ignited vendor, meaning you get $4,000 a year to spend on certification training. And you can do that with us. You could get your Linux Plus, your Cloud Plus, your Security Plus, or your CCNA, all for free with a voucher and lifetime access to our learning management system. If you're in a unit or corporation that wants in-person training, we also do that as well. We bring our test center, our whole lab, our stations, everything that you'll need for a good in-person boot camp. So I want to thank everyone for viewing, and don't forget to like and subscribe.